Okay, so we're going to be doing lesson 3. And again, I saved this for the very end. I'm going to just be using the note package. So link note package available on the Google Classroom. What we're going to do is we're going to solve this first question, which is one we've done before. Okay, so I want you just to write the cosine of x is equal to negative root 3 over 2. Okay, so write that guy down. We know that cosine is negative. So according to CAST, I am going to have solutions in the two quadrants where cos is negative, which would be in this quadrant and in this quadrant. And then we need to figure out what the reference angle is where x is root 3 over 2. So Cohen, what would that reference angle be where x is root 3 over 2? 30 degrees, yes. So my reference angle, theta r, is equal to 30 degrees. And what we need to figure out is if there's a 30-degree reference angle, what would that rotational angle be? So that rotational angle, Nathan, would be what? If the reference angle is 30 degrees, what would the rotational angle be? 150. So one of my solutions is going to be 150 degrees. And then I have a terminal arm in this quadrant. So again, think of the rotational angle to get the solution. And Jackson, what would that solution be? 210 degrees is correct. Okay, so now what we're going to do is we're going to figure out the solutions for this one. So let's write it off to the side. Cos of 2x, so a double angle for cos, is equal to negative root 3 over 2. So it's the exact same question, except the only change is I'm changing my argument from x to 2x. So this is a double angle. What we're going to do, remember I said if you're strong at graphing, you'll always be able to get the solutions. So first we're going to get the solutions by graphing this, and then I'm going to show you how you would algebraically solve this question. So remember that when we graph, this will be my y1. This is going to be y2. So it's going to be an intersect method. My domain restriction right here is telling me that I need to be in degree mode and what to set my calculator to. So I'm in degree mode. I'm going to type in the double angle of cos. So we're able to do that. You're able to double your argument. So cos of 2x, that's going to be equal to negative root 3 over 2. Okay. I'm going to change my window right away. And I'm going to change it to follow the domain restriction. So 0 to 360. If I was in radian mode, I always change my scale to pi over 6, but we're in degree mode, so pi over 6 is 30 degrees. And then I'm going to have a straight line going through negative root 3 over 2. So remember, our cos graph goes up to 1, down to negative 1, right? So let's change my y min to be negative 1 and my y max to be 1. Okay, so here's my picture here. I want you to get those 4 solutions. And what you could do, pick 2 of them. Like some of you pick these 2, some of you pick these 2, and then I'll pick 4 different people to give me the answer. So remember, it's second, calculate, and intersect. I will do the far left one, so you don't have to do that one. So that solution, x. So 75 degrees is one solution. And you guys get the other ones. So get this guy, and this guy. Kenji, give me one of your values for x. 105. Okay, so this one is 105, and that's correct. Bella, do you have that third one? 255. Mark R, do you have the last one? Who has the last one done? What do you have? 285. Okay. So again, we've never done a question so far with a double angle like this. You'll be able to get your answer, right? And then I'll show you now how to do it algebraically. Before we do that though, you could sort of notice something. So the only thing that I changed in these two equations, everything is identical except for the argument. This is x and this is 2x, okay? So I sort of doubled the argument. In terms of the number of solutions. So when I double my argument, what do you guys notice about the number of solutions? They were doubled, okay? So in this answer, my argument was doubled. I actually have double the solutions. Right? I had 2 solutions in A and I've got 4 solutions in B. And then what it wants you to do for this, we'll just sort of talk about this. It sort of wants you to see, do you see kind of like a pattern happening? And then this first solution was 75. And then 210. They get these two solutions. And I'm going to show you that when we split it. Okay, so let's algebraically solve this. So first what I want you to do is I want you to write the cosine of x is equal to negative root 3 over 2. And then I want you to write the cosine of 2x is equal to negative root 3 over 2. The domain restriction we were originally given was x is less than or equal to 360, greater than or equal to 0. Okay, so this is what we're used to solving, right? We solved this in Trig 1. But again, how we did this is we said, okay, past solutions were cosine quadrants 2 and in quadrants 3. Reference angle is, our reference angle is the inverse cos of the absolute value of negative root 3 over 2, which is root 3 over 2. So where is x on my unit circle, root 3 over 2? Well, that would be 30 degrees, right? So that was our reference angle, 30 degrees. And then we said, okay, we need to put a terminal arm in this quadrant, which is what we already did in the previous question. And we know that 180 minus 30 would give me an x value of 150 degrees. And we know that 180 plus 30 would give me an x value of 210 degrees. Okay, so that's how we got those two solutions of 150, 210. Now we got to get those 4 solutions. How do we get those 4 solutions? So the first thing we have to do is this. We have to manipulate our domain because our domain is for a single x. Our domain is for if our argument is x, but what I'm doing right now is my argument is 2x. So what I need to do is I need to manipulate this current domain so that instead of an x here, it fits this argument, which would be 2x. So if I want this to be a 2x because my argument is 2x, what I would need to do is I need to multiply this by 2, and you're going to do that to the entire domain. We're going to multiply everything by 2. So now my domain fits what the argument is. Okay, so if this was 2x, now my domain is going to be 2x. Except what's going to happen is 360 times 2 is 720. 0 times 2 is just 0. So what I've done is by doubling my domain, how many times around the circle am I now going? I'm going twice around the circle, okay? So watch what's going to happen. I know that, again, according to cast, I'm going to have a solution here at 30-degree reference angle, and I'm going to have a solution here, 30-degree reference angle. Instead of writing x is equal to, because this one we had a single x here for our argument, what I'm going to now do is my argument is 2x. So I'm going to write 2x is equal to. This solution here, I know that that solution would be 150 degrees, right? We know from over here it's 150 degrees. So let's write 150 degrees. I know that this solution is 210 degrees. But then, because I've doubled my domain, I need to be able to go twice around the circle. So I need to find what's coterminal with this 150 degrees. So remember to find what's coterminal with 150 degrees. If I add 360, I'm going to be coterminal. So if I add 150 degrees plus 360 degrees, that is going to get me to 510. Okay, so just write this down for right now. 150 plus 360 is going to give me 510. So I have a solution of 510 degrees. And remember this one, this solution was 210, right? So this guy was 210, but that's only once around the circle. I could now go twice around the circle. So 210, what's coterminal with that? If I add 360 degrees to 210, I would get 570 degrees. Okay, so I've got 570 degrees. And you might say, well, these numbers don't match those four numbers that we got. They have to be these answers, 75, 105, 255, 285. Well, I have 2x is equal to this. Do you know what I'm going to do to get x by itself? I'm going to divide everything by 2. So I'm going to divide this by 2, this by 2, this by 2. Everything's getting divided by 2. If I divide by 2, I have my 4 solutions. 150 divided by 2, there was that 75 degrees. 210 divided by 2 is 105 degrees. 510 divided by 2 is 255 degrees. And 570 divided by 2 will give us that 285. Okay. So chances are you'd see a question like this on a numeric response, let's say, where you could just graph it. But we're just going to do some questions where we're algebraically solving so you can understand how to solve it algebraically. Okay, let's look at the next one. So that's all we're going to be doing. Sine of 2x is equal to negative. So first of all, let's just write what the solution would have been if it was the sine of x was negative 1/2. So just write that down. If the sine of x was negative 1/2, we would have said, okay, according to cast, we're dealing with sine this time. Sine is negative in the tan quadrant and in the cos quadrant. So I'm going to have two solutions. I'm going to have a solution here and a solution here. The reference angle, we need to find out where is y 1/2. And what would the reference angle be in radian mode, Emery? Where is y 1/2? Pi over 6. Yep. So 30 degrees again, but pi over 6. Okay. So in this quadrant and in this quadrant, we have two different answers, right? So my two different answers in this quadrant here, y is negative 1/2. Do you know what, anybody remember what that is? Seven pi over 6. This one would be 7 pi over 6. And this guy would be 11 pi over 6. So x is equal to 7 pi over 6 and 11 pi over 6. That would be the solution if my argument was just x. Okay, the question is though, the sine of 2x is equal to negative 1/2. So it's the same thing. According to CAST, we're in the same two quadrants. Sine is negative here and here. Except what we have to do is if our argument is doubled, we have to double the domain to reflect that. So our domain is this guy. And if I want to reflect it to have a double angle, I know this by 2, this by 2, and this by 2. So my new domain is from 0 to 4 pi, which essentially means I need to give solutions twice around the circle, is what that would be. So you doubled the domain, we're now going twice around the circle. Okay, so x, oh, sorry, there should be a 2x here. So now what I write is I write 2x is equal to, because I don't have x anymore, I've got 2x here. So 2x is equal to, this was one of our solutions, which was 7 pi over 6. This was a solution where y is negative 1/2, and that was 11 pi over 6. I need to go twice around the circle, so that means I need to find what's coterminal with 7 pi over 6. So 7 pi over 6 plus 2 pi. Okay, I need to find what's coterminal with that. So multiply this by 6 and multiply this by 6. That is giving me, this is 12 pi plus 7 pi. That would be 19 pi over 6. So that's a solution. And then I need to find what's coterminal with 11 pi over 6. So 11 pi over 6, what's coterminal with that? So put this guy over 6, multiply this by 6. So I've got 12 pi and 11 pi, which is going to be 23 pi over 6. Okay, so I doubled my domain, doubled my argument, doubled my number of solutions. That's what 2x is equal to. I need to find what x is equal to. So I'm going to divide this by 2. And each of these numbers, I'm going to divide by 2. X is equal to, it's actually quite, it looks complicated, but it's not. 7 pi over 6 divided by 2 would be the same thing as 7 pi over 6 times 1 over 2, which would be what? 7 pi over, so think about it. 7 pi over 6 divided by 2 is the same thing as times 1 over 2. So you just, it would be 7 pi over 12. So the first solution would be 7 pi over 12. This one would be 11 pi over 12, 19 pi over 12, and 23 pi over 12. Not that I've seen, no. You'd recognize it if it did, but, and that's how we get the answer. Okay, let's do one more like this. Determine the exact values of theta in this equation here. So the first thing we need to do is we need to isolate our cos ratio. So get your cos ratio by itself, get rid of that 2 in front by dividing both sides by 2. Okay. We are dealing with cosine, and cosine is positive. So cosine is positive in this quadrant and in this quadrant. I am looking for the reference angle where my x coordinate is 1/2. Angel, what would that be where the x coordinate is 1/2? Sorry? Pi over 3, yep. So pi over 3 is my reference angle. So it was 60 degrees. So here, that angle in standard position is pi over 3. The one down here, the angle in standard position, where x is 1/2, is 5 pi over 3. Okay. I'm going to write the domain given. So theta is less than or equal to 2 pi, greater than or equal to 0. I'm going to double my domain. My argument is a double angle. So I'm going to multiply this by 2, this by 2, and this by 2. I now need to give solutions twice around the circle, is what I need to do. And my solutions aren't going to be right now theta is equal to, they're going to be 2 theta is equal to. So I know that once around the circle, I have solutions at pi over 3 and 5 pi over 3. So now I need to find what's coterminal to pi over 3 and to 5 pi over 3, because I need to go twice around the circle. So pi over 3 plus 2 pi is going to give me 1 pi plus 6 pi is 7 pi over 3. That would be a solution. And I need to find what's coterminal to 5 pi over 3. So 5 pi plus 6 pi will be 11 pi over 3. And now I need to get theta by itself by dividing all of my solutions by 2. Jack S, pi over 3 divided by 2 would be what? Yeah. Yes. For okay, and those would be your answers. What's that? Okay, let's do 2 more questions that are going to be different. One's going to be a diploma style question that I've seen before. And actually, before we do this one, let's do this one. Okay, so students look at this. I've seen a question similar to this on a diploma, and I'm going to show you how you could actually logic your way through this question. So students will look at this and they'll say, oh, this is a different identity for cos. And yes, it is a different identity for cos, but we're actually going to solve it not even using the difference identity. Solve it in a totally different way just by using logic. So let's write what we were given, which is the cos. My argument is x minus 20 degrees, and that's equal to 1/2. And what it says it wants a solution, so we got to figure out what x is, okay? And it says that x is going to be within this domain here. So let's actually just quickly show where x is going to be. They're saying x is less than 90 degrees and greater than 0 degrees. So where do they want my arm to land? In what quadrant? Yeah, it's going to land in quadrant 1 somewhere, right? My x has got to be somewhere within here. Okay, what we're going to do is we're just going to sort of ignore this x minus 20. If I said to you the cosine of theta is equal to 1/2. Yeah, the cosine of theta is equal to 1/2. We're looking for where is x 1/2. Where is x 1/2 within this quadrant? Pi over 6. Okay, which is how many, because we're in degrees actually, 60 degrees. So at 60 degrees, if this was 60 degrees, I know that my x is 1/2, and this would be root 3 over 2. But at 60 degrees, my x value is 1/2. So I know that the cosine of 60 degrees is 1/2. Look at this argument and look at this argument and see if you could figure out what would x be. So this argument is x minus 20. This argument is 60, but they're equal. So watch what I could do. I could take this argument. Some of you might be able to see what x would be. Do you know what x would be? It'd be 80. Yeah, you got to get 80 degrees. But x minus 20 degrees, so take that argument. I know it has to equal to 60 degrees. X is equal to 80 degrees. Okay? Because again, if I put 80 up here, 80 minus 20 is 60. 60 degrees is the place on the unit circle where the x value is 1/2. This is like a classic diploma style question where you just have to know things on the unit circle to solve. We could solve it after, like later on, we could solve it that way, but this would be the easiest way to do this question. Okay, let's do this last one because this is a little bit confusing. So yesterday in lesson 8, what we were doing is we were trying to write equations so that we only have cos in there or we only have sine in there so that we're able to solve. And I can't write, I can't take cos out or sine out. I can't do anything like that for this one. So it's like, how are we going to solve this? First, you could punch this in your calculator. You could punch in y1, y2, and you will get the answer. Okay, so let's actually get the answer that way first of all, because I don't want you to panic on a test if you're like, I just can't remember the algebra for it, because all these could be gotten on our calculator. So 4 cos of x sine of x, I'm going to have a horizontal line going through 1, so that's going to help me change my window. I know I need to be in degree mode. I'm in degree mode. I'm going to change my window in 8. Like I said, I like going up to 30. I'm not going to go -1 to 1. I need to go past because I know that this is going to give me a straight line through 1. So I'm actually in this window, how many solutions do I have? I have 2 solutions. Solution here. So let's get those solutions. Second, calculate interval. So let's write x is equal to 15 degrees. And my other solution, 75, okay, 75 degrees. Those are answers. So a numeric response question could be, what's the largest solution? It would be 75, right? The other version test might say, what's the smallest solution? It'd be 15. I'm going to show you how you could use an identity to solve this. For cosec sin x doesn't completely match one of these, but it's really close to one of these. Which one is it really close to? This guy here. Okay, so watch what we could do. I could rewrite this as, here's the identity, 2 sine x cos x. This guy's equal to 1. But if I need this to truly be a 4, what number am I going to put on the outside? 2. Yeah, I'm going to just put a 2 on the outside. Because this is the exact same thing as 4 cosec sine x. Okay? Now, watch what I could do. What was the identity for this guy? 2 sine x cos x is the same thing as sine of 2x. Okay, let's get sine of 2x by itself. I could either type in, again, left side, right side on my calculator, I get those 2 answers, or we'll do what we just did. Let's do what we just did to review how we solve that. Okay, so on my unit circle, according to CAST, sine is positive in these 2 quadrants. Where is y on my unit circle 1/2? Actually, I've got over 6 and at 5 pi over 6, right? Those are my 2 answers. I'm going to write my domain, though, because this was a double angle question. It wasn't equal to. So the domain that they gave me was, they said, stay within this domain here. I'm going to double the domain because this one's doubled. Conversely, you guys, if this was a 3x, what would you do to all of these? You'd multiply by 3. If it was a 4x, you'd multiply by 4. Right? But I need to get a 2x, so I'm going to multiply this by 2, this by 2, and this by 2. 0 is less than 2x less than 360 degrees. Okay, so now I have to stay within this, which is only one time around the circle, right? One time around the circle. So 2x is equal to, this was a solution at 30 degrees and 150. So 2x is equal to 30 degrees and 150 degrees. Would I add 360 to each of those, or no? Because I would be outside of this domain from 0 to 360. This is only once around the circle, and I've already got my 2 solutions once around the circle, right? It was 30 degrees and it was 150, but now I got to get x. So I divide this by 2, this by 2, and this by 2. X is equal to 15 degrees, and 150 divided by 2 is 75 degrees. Okay. Do you have to know this algebraically for the exam, these questions? No. Every question you get, you'd be able to punch in your calculator if you want. Would you maybe have to do it on the diploma? Maybe. right? I'm going to give you, there can't be 4 solutions, even though my domain was doubled. Because this was 0 to 180, I just need answers from 0 to 360. And the only places on my unit circle where y is 1/2 are just those 2 places. Yep. Okay, so if you want to practice a couple of these questions, here's what you would do on page 613. Question 1A, it's good because it's a calculator question. So 1A you'd see on your exam. Okay, you're just solving using the calculator. 4A is solving a double angle using algebra. Do it using algebra, right? Like make sure you're good with it. Question 7 is going to be a question of a graph from Trig 1, but it's a good question. So those would be the questions that you would do just to practice some of this. And then what we'll do right now is open up your book to that practice test. So I will give you the practice test questions. Tuesday after the long weekend. Okay, I'll show you where the videos are. Okay, practice test is on page 655, so open up to that. It is a really good practice test. You're going to do these questions before you do any other. I've got a review package I could give you that you would do tomorrow when you finish off this. I would take note into doing all of the ones that I've assigned, but pay particular attention to anything that I've starred. So circle number 1 to 4, circle and star 5, circle NR2, and write calculator. Okay, I just expect that to be, it's a numeric response. You punch it in the calculator. Don't bother doing algebra for numeric response. 6, 9, 11 is starred. 12, 14, NR3, 15 is starred. NR4, I got a double star for some reason. Again, calculator. You write, don't bother doing it algebraically. Some of these questions are designed, can they figure out that they could just punch this into their calculator? 17, 18, 20, and I want you to write next to NR6, that is a calculator question. If you want, I could upload the work teacher solutions for these. I will do that actually. I'm going to upload the work teacher solutions because I know some of you are going to get stuck on this guy. Cosecant, what's the reciprocal of cosecant? Sine of x. So figure out this question is going to be a sum identity for sine. So use your formula sheet and figure out what was the sum identity for sine. Can I borrow yours for a second? So sum identity for sine was sine, remember this guy's your alpha, this is b. So sum identity for sine was sine of alpha cosine of b plus cos of b, no, cos of a sine of b. Cos of a sine of b. Okay. So that would be the sine of alpha. Alpha is pi over 2. Cosine of b, which is x, plus cosine of pi over 2 sine of x. Pi over 2 is right here, which is 0 and 1. So the sine of pi over 2, what's the sine of pi over 2? 1. So that is 1 times the cos of x plus the cos of pi over 2 is 0 times the sine of x. What we are left with, 0, anything times 0 is 0. So this eliminates. And we're just left with 1 times the cos of x, which is equal to the cos of x. Now, that would be the answer if the identity was sine, if the trig ratio was sine, but the trig ratio is cosecant, which means what do I have to do with this answer? This is over 1. So this answer is 1 over cos of x, right? And 1 over cos of x, secant of x.